Guys, we have our results. And this is one of the big moments you savor as a data scientist because we don't see how bad they are yet. I mean, they might be awesome, and in fact, we assume they are. We assume we're going to see a list of like Aaron at the top and Aardvark and Abacus and whatever else comes in, and there'll be like 1,000 occurrences each or something, and it's going to be super informative and interesting and awesome. And in reality, here's what we have instead. 0, 0, 0, 0, 0, 0. This goes on for a while. And we have some things like this. Real Vlivly, this is probably some markup stuff somewhere, or possibly corrupted data uploaded into Wikipedia. Either way, this is not quite the paragon of usefulness that we might have hoped for from an experiment like this. Is it really a problem? I mean, did we do something wrong? I would say no, and depending on who you ask, you're going to get different answers about that. But here's why. We have a too much data problem in the word listing here. That's fine, right? We have far less data in the word listing, 308 megabytes, than we did in Wikipedia to start with, 15 gigs. Both of these are compressed. So what we don't have is a final answer, but what we do have is a much smaller problem, and so we can much more quickly check and iterate on this data set than we could by running the original, which took many hours. And I think that's the right way to look at this, right? We've reduced it down, and so that was a step of progress. And then there's going to be another step where we take this and condense it down to an actual list of recognizable words as opposed to mostly garbage. So how do we get recognizable words? Just so happens that Linux usually ships with a file called user share dict words. And this is just a list of words in the English language sorted by, sorted alphabetically. You'll notice something interesting here, and something I kind of glossed over in the last video where we were working with this. These all start with uppercase letters, and they go uppercase A down to uppercase B before they hit any lowercase a and b. And remember how I was talking about how when we did the sort, we saw uppercase and lowercase grouped together in the word list. That is a consequence of an environment variable called lang, which defaults in Ubuntu to EN US UTF-8. What this means is US English encoded in UTF-8. We don't want that. And this is something I tweaked about the pipeline before I reran it. So the output here is from a rerun. And it made it about twice as fast. If you export lang equals C, then it will not attempt to do case folding when it does the comparison, and you'll get something ordered like user share dict words, where there's no case folding happening here, right? It's just ASCII is how it's comparing stuff, or maybe not strictly ASCII, but it's close. Anyway, that's the thing to consider. And by the way, you would run into something similar on Hadoop as well. You have custom comparators and stuff, and you always have to think about like, how am I comparing my keys when I group things. I'll talk more about Hadoop and such later on. I kind of want to build up the fundamentals with this example here. So anyway, we have these results. What do we do to get this into a usable list? We have user share dict words. We have these, and these are sorted the same way. I exported lang equals C before I ran the sort here, so we should have these things ordered the same, and that's important for us because we can use a tool called join. And I think I mentioned it, but I don't think I went into detail. So join does the SQL style inner join by default. You can also have it do outer joins. And we're going to use an inner join in this case. In order to make that work though, we need to do some delimiter stuff. This is a common thing when you're working with UNIX utilities. If you look at the actual bytes here, XXD is a tool that lets you do this. Let's see. If we have it installed. There we go. It's not super clear what's going on, but these are the actual bytes. You're going to see a lot of, I think, just spaces. ASCII 20 is a space. Actually, this is, oh, right. The first line is not very useful. We want the second, we want a line that begins, yeah, so here's some white space here. Yeah, here we go. So we're being padded out by spaces. 0a is a new line, 20a is a space. These are all hex, by the way. And then there's a space after the number before the word, which looks about right. So there are a few ways that we can convert this, but we want ultimately to get tab delimited, because tab delimited is pretty well accepted by Unix utilities. So let's do some scripting. Actually, we might not even need to. Let's try doing this first. We can use awk. If we do this, we'll just get the counts. Yeah, and then if we do this, I think we'll get counts jammed right together with words. Oh, there's a white space. That's actually really convenient. Okay, so if we do this, oh, that's terrible. I don't know awk very well. I'm used to using Perl for this. If we did Perl, we could say this. There we go. Now we have tab delimited. Quick explanation on what this is. Perl-A is magic that says break each line into white space delimited values in the uppercase F array. Perl is deeply magical, but in very useful ways. N means do whatever thing you're going to do for every line of input. And then E just says evaluate this code in quotes. So it's going to evaluate print, this thing. The end result of which is that Perl's writing a loop for us and then just sticking this print statement inside the loop. And it's also splitting each line. It's really useful. And I recommend learning a lot of Perl one-liners if you're going to be doing this kind of data conversion. So we have this, which is a great start. Now, ideally, we don't decompress this fully because I'm a big stickler about that. So we're going to use bash process substitution for a file name, and this is really cool. If we go up here, we see join, and it's got options file 1, file 2. You'll notice that things join can only read one side from standard input. Actually, we could read this from standard input, couldn't we? We could say like join dash user share dict words, and I think we'd have to tell it something about the field on the left is going to be field 1 or field number 2. Sorry, it's the second field. So if we did this, interesting. So it's not completely agreeing about the sort ordering, but I think that's okay. Just a warning. Skipping. I want to see if this works. I might be a little bit wrong here. Let me use PV just so I understand. No. Something's wrong with this picture. Oh. Okay. Oh, I never set up the field separator. That would be why. You always have to do that. So the field separator should have a default. Yeah, leading blanks, separate fields. Okay, well, I'm not totally clear on what that means, but we can just do this. That might do what we want. Boy, that doesn't do what we want, does it? Actually, I'm not quite clear on that yet because this looks better, right? We have a tab here. That's good. Oh, it's complaining about both sides, isn't it? Both sides aren't sorted, so we're going to miss a bunch of data if we do this. Okay. That's fine. Yeah, we missed a ton of stuff. Oh, yeah, I forgot to export the lang in this. Yeah, that would be why. Okay, never mind. Both files are sorted by the C locale, not EN US UTF-8. So of course join was confused. A quick aside on that, by the way. Join delegates to libc, I believe, for string comparisons, and libc is going to be the thing that looks for this environment variable and figures it all out. So when you're doing these things, a lot of this functionality is actually inside libc. There we go. Look at that. We now have actually usable word counts, and these are cool. I mean, this is like real looking numbers of word occurrences. I'm going to save this into a file so that we can play with it and potentially import it into SQLite. And here is what that looks like. realwords.gz. It's good practice to use PV with this. I'm going to go ahead and cancel that and do it. Oops. What is it? Word count. Singular. There we go. What was I saying? Oh, right. I'm exporting this into a separate file. That way we're doing the bulk of the work up front. This is a process where we're still like removing most of the content. And so it makes sense for us to go ahead and collapse it down, save the result, and then the result we get will be probably, I don't know, 10% or less of the original. We can take a look about how it's progressing. Oh, we haven't even written any data yet. That's surprising. Huh, okay. There we go. Oh, look at that. 1,000th the size. That is awesome. Okay. By the way, I'm doing something here, less realwords.gz. You're not supposed to be able to do this. I was surprised when I could. There is a tool called zless, or more canonically, you would gzip dc pipe less. But I guess less is smart enough in Linux to decompress gzip files. I wouldn't rely on that behavior. I don't think it's true everywhere. I think it's a Linux thing. Okay, anyway, we have this list of words, and it looks great. This looks believable so far. And let's see. Okay, let's suppose we want to find the most common words. Obvious, easy thing you might want to do. We could do it a couple of ways. First is you could use sort. So real words sort-rn reverse numeric is what that is. And I'm going to need to look up sort real quick to figure out how to specify the field, because we don't want the first field. The first field is the word. We want the second field. Key def gives location and type. I think it's -k2, (2) or something, or -k2 maybe. Let's try that. Oh, there we go. That was easy. So the, of, and, in, ref. Ref is noise. That's totally noise. To, a, amp is noise from XML. Is s, probably apostrophe s, for title, so forth. Title is noise from like HTML or XML attributes. Actually, no, this isn't, sorry, this would be wiki markup attributes. Anyway, so that was one way we can do it. The other way to do this, and I think at this point it probably makes sense to think this way, is to import this as a tab delimited value into something like SQLite, which we can install. I think it might be SQLite 3 instead of SQLite. I'm not sure. No, apparently. Oh, I see. Yeah, it depends on SQLite 3. So SQLite has an import syntax, and I don't know if it'll import from a shell process. I kind of hope it does, but let's find out. So SQLite 3 help. Okay. Something like we can do import file table. Let's start there. There should be a way to like run a shell script and capture the output specifically. So, well, maybe not though. I'm thinking that there would be, because like you might want to stream it over the network or decompress things or whatever, but it's all getting stored on disk inside SQLite anyway, and SQLite is not a very efficient storage format in terms of space. So maybe they said, well, it doesn't really matter. In that case, let's just do it this way. Let's decompress our realwords.gz. All right, so now we have this list, and now we can just import. I don't think we're in a database. Let's fix that. Words.db. So now we're in a database nominally. Import real words into words. Okay. Is it schema? Oh, that's not right. Create table words. Okay. Well, it did import it. It just said everything is, yeah, there. Okay, so it's expecting field headers, and okay, it expects the top line to be a field header, and we haven't told it the separator. I think it's using the default separator of pipe or something. And there's a way you can change that. You can say, what is it? It's like format. Or, you know what? Let's just Google it. Stack Overflow always has the answer to things like this. There we go. Dot import. Yep. Okay. Oh, dot separator. That's how. Okay. Oh, cool. Okay, if we create the table up front, it won't infer the schema. That's kind of what we want. So drop table words and then create table words, word text, count it. I think that should be fine. So now when we do this, schema should be, of course, the same. Select star from words, limit 1. There we go. Limit 10. Awesome. So now we can do this. We can say select star from words, order by count descending, limit 10. And so we have, you know, the top n words. I think that's kind of where I want to end this. We've covered a fair amount of ground here. And I think, yeah, I think we'll probably wrap this up, and then in the next video we'll talk more about the OSM project, which I kind of left hanging for a minute. So I will see you guys then.